Okay, so now let's discuss a little bit on some additional facilities that assembler provides for the assembler programmer, whoever is writing programming in assembly languages. Assembler's main function is to generate an object file, object code, okay, for the linker to link in and generate an executable. Now, assembler provides some additional facility to ease up our assembly programming. Okay, so let's look at that, some of them. First of all, it has provided some data layout directives and provide easier way to describe my data for the program. It provides something called macros. It provides a way to shorten the code writing for the repetitive code. Uh, and pseudo instruction combines two or more fundamental instructions into one single instructions. Okay, so basically about the pseudo instruction, what I can say that usually any processor has very limited number of instruction. Okay, if you look at this instruction set, maybe 96 different instruction or 100, maybe 120 instruction, not more than that, not more than that. In fact, if you look at the MIPS green sheet of your textbook, first page of your textbook, you will see that there are only way less than 100. I think there are like 50 or so, about over 50 or 60 instruction only, and all all the complex software is translated with those limited number of basic instructions. Okay, now pseudo instruction, what are they? Sometimes like uh, we can sometimes we can think of a little complex instruction, called little complex instruction, which can be broken down into two or more basic instruction. So sometimes assembler provides that abstraction to you, like, okay, you write something in the pseudo instruction, and the assembler will break them up into basic instructions, like two or three basic instructions. That way it will ease up your writing of the assembly program. Whereas macro is you are naming a series of code which can be like 10 lines, 15 lines, even can be 2 line, 3 line, of course, code, and you are grouping them and naming that code as some macronym, and then you can refer to that name later, so that that code become repetitively replacing your macro references. Okay, another point to note that sometimes people confuses macro referencing to the function call. So there is nothing called a function call per se in assembly. Okay, it's always an and like an macro replacement happens. We'll describe that more in later, but just a point of caution that don't try to think a macro referencing as a function call. Okay, second point is that you can think of pseudo instruction as an assembler provided predefined macros. Assembler provided predefined macros, but really don't kind of also think in that that's really a macro you are writing and stuff like that. Is a little bit different mechanism there, but loosely saying that pseudo instructions are kinda macros provided for general purpose to combine two or three common basic instruction into some common functionality. That's what you can think of. Now let's first look at the data layout for this for facilities, like for example of the string, right? In the high level program, you define string constant everywhere, like especially during the printf kind of things, you are actually defining some format string there, and you are typing some, okay, my value is this, da da da, etc. So string is widely used constant in a program. How we can define it in terms of assembly, right? if you uh, if you think of a string, right? String we define in the high level program as within double quotation and with some letters inside the double quotation, whatever that letter is, right? So here we are defining, we can define like this. My string is a label, okay, and then followed by some keyword called dot ASCII z, dot ASCII z. Okay, so ASCII z is stands, it's this kind of stands for like I'm going to defining a string followed by a string within the quotation. Okay, now first of all, you all know a label is a name of an address. Okay, somewhere this string will be placed in the memory. This string will be placed in the memory, and the start of that memory, which contains the code for T, that address will be assigned or will be named as my string. Okay, so a label is an address, name of an address. An address is actually given a name which is my string, which starts from the beginning of the address of the string, beginning of the address of the string. All right, so this is like more natural way of defining a string. You just type in there. Now if you really think of what is a string, string is a set of characters. Okay, now what is a character? Like for example, what is T, what is H in terms of computing system? They are nothing but some numeric codes, and that code is called ASCII code, like American Standard Code for Information Interchange. So each character you see on the computer screen is nothing but a numeric code given for, it's a standard code given for each letter that we can print on the screen. So that's a numeric code, that's a 8-bit code, which is a byte type information, 8-bit code. That means instead of writing in a natural way within the quotation and all these characters, we can also explicitly define using byte code equivalent of the ASCII code. Okay, and then now you can probably realize why these directives, this is anything dot something is the assembler directive. Why this assembler directive of dot ASCII z comes along? It comes from that ASCII, American Standard Code for Information Interchange. I am defining this in ASCII. So take it, convert. So what we are telling assembler, convert this letter what I am typing to its corresponding ASCII byte code and place it in a memory. Okay, that's my string. So alternate way of my string definition, you are practically encoding all the ASCII codes. Like if you look at the cross reference to the ASCII code table, you will see T is 84, H is 104, E is 101, space is 32, small s is 115, and so on and so forth. So here what this directive dot byte directive means is that place this byte from starting from a memory which is labeled as my string to 84, then 104, 101, 32, etc., etc. So we'll look at this memory layout and how that my string address is determined in the successive lectures. Okay, so just for timing, just assume that somehow we can determine start of this whole memory layout. What is the address from where we assembler need to put the 84 and then 104, how it is organized inside the physical memory, and so on and so forth. We'll review that, but for timing, just take it that we know that that part. So we determine the start address of my string, that label, and we name that address as a my string, and then start putting this byte in order, sequential order, 84, 104, 101, 32, 4. So we are explicitly writing this. And last but not the least, if you notice, last byte is 0. So remember, any string termination in the high level programming is terminated with a null character. If a string is not terminated with a null character, it's a runaway string. So system doesn't know. System only assumes that from a start of the string, the end of the string is there is a null character or zero ASCII code. Okay. So now come back to this ASCII Z directive once more. So this ASCII Z is a string here. You don't see the null character anywhere, right? So ASCII Z directive, it automatically puts the null character at the end of the string. So after this carriage return character /n, it will automatically put a null characters \0. Okay, and that will kind of translate into the byte as a 0 ASCII code. There is another directive called .ASCII. Okay, not ASCII Z. There is a directive called .ASCII which does not append a null character to the given string. So if you are using a .ASCII, in that case you need to explicitly make a null character into the string. You need to declare a null character into the string definition itself. Okay, so that's the difference between your ASCII .ASCII Z and .ASCII. Now come back to our original point. You see, like we have two ways. Like definitely .byte is more fundamental way of defining a string because we are dealing with is directly the ASCII code. We are laying down letter by letter. But this is a lot of problem for whoever is writing the program, right? So for every string, you first need to go and look at the ASCII table and then determine what's my byte code is and then put there, right? Lot of like slow down there, right, in writing a program. So that's one way that your assembler is helping us to using this directive .ASCII Z, and you can naturally type in your string. This from .ASCII Z to corresponding byte conversion, your assembler takes care of it. Assembler has a table, lookup table for each of the character, what that character ASCII code is, and it replaces ASCII Z with series of bytes. Like conceptually, you can think of series of bytes. That conversion is taken care by your assembler. So that is one facility.